When you send some traffic to an IP address that's not on the same network or subnet, you need a layer 3 device to route the traffic between different networks. But how does a layer 3 device, let's say a router, know how to do that? You see, on a router, there are routing tables that have information on how to get to certain networks. You can populate this information manually by creating static routes, but managing static configurations can be very time-consuming. If a link fails somewhere on the network, a static route will not adapt to the new situation in the network. For each such case, a manual intervention will be needed. On the other hand, dynamic routing protocols can adapt quickly whenever there is a change in the topology. The method that a routing protocol uses to accomplish this purpose depends on two things: the algorithm that it uses and the operational characteristics of this protocol. The operations of dynamic routing protocols vary depending on the type of routing protocol and on the routing protocol itself. But what is a routing protocol? It's just a set of processes, algorithms, and messages that are used to exchange routing information. Routing information is used to populate the routing table with the best paths to destinations on the network. As routers learn of changes to network reachability, this information is dynamically passed on to other routers. You can also distinguish between routing protocols based on whether they route traffic within an autonomous system or between different autonomous systems. An AS, otherwise known as a routing domain, is a collection of routers under a common administration or a service provider network. Internal gateway protocols, or IGPs, are used to exchange routing information within an AS. Common IGPs are, let's say, EIGRP, ISIS, OSPF, and RIP. You would use these protocols in a typical enterprise network environment. Now, to route between different autonomous systems, you need to use an external gateway protocol, or EGP. BGP is the EGP of choice in networks today and is responsible for routing between different internet service providers. You can further classify internal gateway protocols as distance vector or link state routing protocols. The distance vector routing approach determines the direction and distance, for example, hop count, to any link in the network. Distance vector protocols periodically send complete routing tables to all connected regions. You can imagine that this can be an issue in large networks. These routing updates can become huge and cause significant traffic on the links. You see, here's the thing. Distance vector routing protocols do not actually have a map of the network topology as link state protocols do. The only information that a router knows about a remote network is the distance or metric to reach this network and which path or interface to use to get there. RIP is an example of a distance vector routing protocol. So unlike distance vector protocols, the link state protocols create an abstract of the exact topology of the entire network. You could say that a link state routing protocol has a complete map of the network topology. This is the complete difference between distance vector and link state protocols. A link state router uses the link state information to create a topology map and to select the best path to all destination networks in the topology. OSPF and ISIS are examples of link state routing protocols. Another routing protocol categorization you can use is this. You can define a routing protocol as either classful or classless. Modern routing protocols are classless to address the limitations of classful routing protocols, such as RIP version 1 and IGRP. What kind of limitations do I mean here? A prime limitation of classful routing protocols is that the subnet mask is not exchanged during the routing update process. This limitation means the same subnet mask must be used on all subnetworks within the same major network. When you consider point-to-point serial WAN connections, using a 24-bit prefix is very wasteful when all that is required is a 30-bit network prefix to accommodate two endpoints. Another limitation of the classful approach is the need to automatically summarize to the classful network number at all network boundaries. In the classless routing protocols, the summarization process is controlled manually and can be usually invoked at any bit position within the address. But the subnet routes are propagated throughout the routing domain. You may need manual summarization to keep the size of the routing tables manageable. Classless routing protocols include RIP version 2, EIGRP, OSPF, and ISIS.